Okay, this is a excuse me. This is a question about Lenz Law and the application of Lenz's law, which states that an induced current will try to oppose whatever it is that is creating it. So it's going to be opposite of whatever the change is in order to oppose that change. Okay, so first things first here, we've got this set up and we see that current is flowing in this direction here when the switch is closed. So what that means is that the magnetic field that's created, when we flip the switch, okay, so when the switch is flipped, the increase in current is going to make a magnetic field. Okay. And as that field strength increases, the coil, the current in the induced coil, or the induced current, in the coil will be in the opposite direction. Now really that is actually very momentarily, because this is a DC source, so as soon as the current is actually flowing and is not changing anymore, there won't be an induced current. But we don't actually have to mention, just when the switch is flipped, that second, that's what's going to happen, is there's going to be a current that flows in the opposite direction. Okay? Now when we open the switch, the current will stop. The magnetic field is going to go to zero. The current in the induced current in the other coil is going to oppose this change, and the direction of the current will switch. Hopefully that's enough for our 4 marks. Okay, so EMF induced in a rotating coil. Here we have an earth inductor, consists of a 500 turn coil. Shows how it's set up. Mean diameter of the coil is 35 centimeters. Figure 6 shows the output recorded for variation of differences with time t when the coil is rotated at 1.5 revolutions per second. So that's my omega is 1.5 hertz. Okay, so it says determine the flux density BH of the horizontal component of the Earth's magnetic field. So I need to use that the EMF is ban omega sine omega t. I'm actually just gonna, if I pick my point to be the maximum EMF, then I don't have to worry about the sine omega, because that's sine is 1 when it's sine omega t is 1 at that point. So we're at 5.6, 5.6. So I would say 5.6 volts. And if I look at the bottom, it's negative 5.6 at the bottom. So my EMF is 5.6 volts. Or sorry, 5.6 microvolts. So be careful about that. This is microvolts, which is 5.6 times 10 to the minus 6 volts. Okay. Area is pi r squared, which is pi times 0.35 over 2 squared. Let's make sure I push every button on the calculator and try not to screw up this time. Zero point 0.096 meters squared. N is 500, and omega is 1.5. So and I get 7.8 times 10 minus 8 Tesla to 2 significant figures. All right, let's take a quick look at the mark scheme, see how I did. Okay, so for 5.1, you get a mark for stating what Lenz's law is, so that the induced current will oppose the change producing it. There's 2 marks available for what happens when you switch it on or switch it off, and 1 mark for completing an argument for switch on and off adequately. So that my answer should get 4 marks. Right, so 5.2, I have made a very, very typical mistake. Okay, so I would probably only get 2 marks for this. The big problem here is omega. It's 1.5 revolutions per second, but I don't need revolutions per second, I need radians per second. Very common mistake to make I really don't have an excuse for why I made it. It's so 2 pi over 1.5. No, 2 pi times 1.5. Where's pi? .4 radians per second, which changes this, because that needs to be 9.4. And there we go, 1.24 times 10 to the minus 8, or 1.2 times 10 to the minus 8, which is what the answer is, because they put the answer as 12.4 nanoteslas. They will accept 2 or 3 significant figures. That's kind of embarrassing.